After this one, it'll be perfect.
All right, this is Mr. Song and Mr. Kurbis, and we are talking about our second video with the HP prime linear regression. So in this example, Bob is experimenting in baking a cake at different temperatures and comparing the height of the cake. Temperature is graphed from 300 degrees Fahrenheit up to 400, and height from 17.4 down to 14.8. Which is the independent variable here, Mr. Song?
Well, we're changing the temperature to see what happens to the height. So temperature should be our independent variable.
Okay, excellent. And the second part of this question asks us to do a scatter plot. We have already come up with the domain and range, well, the set of acceptable scale that we think if we start at 300 and count in every tick is 10, then we come to a nice scale given that grid size. So we'll give you a second, some decision-making skills here, but you can see we plotted the points 300, 17.4. You want to show them where that one is? So 300, 17.4, and so on and so forth. Scatter plot's pretty standard. You should be pretty good at that, but pause for a second and get that done. Okay. Part C, we have the calculator will help us find a best fit, or regression line is better vocabulary, to 4 decimal places. There was a bit of a typo here. Height should be m, the slope or gradient with respect to time, temperature, plus the y-intercept, okay? So the typo in the problem had an mh, but I believe that's fixed now. All right? So what we do on this calculator, we'll go a bit slow, we'll repeat some of the steps, but it's a statistics to var. Okay, nice touch screen on the HP prime here. Then we have already put the temperature into C1, column 1, and the height into C2. Again, pause the video, get that done, and then we will carry on. Okay? So after you've got that, you can unpause, and next, what do you press next?
We go to symbol.
Symbol. So symbol is beside apps. So you press symbol.
Right there. And here, I chose type 1 as linear.
Okay, you have a lot of drop-down options, but we are doing linear regression, so we picked linear.
And this fit, mx plus b, should pop out, and if it doesn't, you go to plot, and if you come back, you'll be able to see that.
Okay, so we already have the result now. So h equals, and we wanted 4 decimal places, so negative 0.0293 t plus 26.5667, all right? Both of those to 4 decimal places, and you see the downward trend there. What does the slope mean in the context of this Bob baking a cake problem?
Well, slope is change in y over change in x. So change in height over change in temperature. So we can say for every degree, the height of the cake decreases by 0.0293 centimeters.
Super. So for every degree Fahrenheit, the height of the cake decreases by 0.0293. Okay, this one's a funny one, isn't it? What does the y-intercept mean in this context?
The y-intercept is when x value is 0 and your x values are temperatures in Fahrenheit. So that would be the height of the cake at 0 degree Fahrenheit.
Does that make much sense?
No, 0 degree Fahrenheit is definitely far, far below freezing. So this is actually an ice cream cake, maybe.
It's not going to rise very much then.
Cake at 0.
So you have to be very careful with linear regression problems because there's context here. So you can only interpolate, makes sense, but you can only extrapolate so far beyond the data, and sometimes you need to determine if the model makes sense or not. So the height of the cake at 0 degrees Fahrenheit, it simply wouldn't make sense. We have data from 300 to 400 degrees. 0 is a far way away from that. Okay, next problem.
Predict the height of the cake baked at 330 degrees Fahrenheit.
Okay, so we should probably show our working and then use the calculator to crunch the numbers.
Let's do that. So h, the height is negative 0.0293 at 330 degrees plus 26.5667.
Okay, so we can get at that pretty quick by...
Going to plot. Oh wait, we have to...
That's all right. If you go to plot, and then at the bottom, you can click on the fit. Click on fit, and there comes your line. Love this touch screen. It's pretty nice. That looks pretty good. Now here's the tricky part. We'll say this a couple times. Make sure your fit is on there, and when you've got the little dot beside your fit, your linear regression, that's trace, shows up. But now we go to, yeah, you're right, sorry. Now we go to
trace, and make sure the dot is highlighted right there next to trace. And then if you press up, you will notice that little cursor when jumped up to the blue line there. Then go to, and I want to know the height at 330 degrees, so I will type in 330 and press enter. And here the answer's right there, but hidden behind the menu. So if you click on menu right there,
there's your prediction. That step's kind of a bit funny with this, why it doesn't pop up right on the screen. So after you've done the trace, you've scrolled to the line, make sure you're not on the dot, move up to the line, and then you do your prediction. You have to hit menu in order to see the 16.9. That took us a little while to get to. Okay?
Okay. Another way to do this question F is to copy and paste the equation into the function. So over here, you're at symbol, and click on that equation and press Shift View, and you see the blue copy over there. Shift blue, and then you've copied the equation. Go to Apps, Function, and you can press Shift Menu, and it'll paste there.
Perfect.
Okay, then I'll plot this, and I'll say menu, go to 330 degrees. And again, it's hidden there, 16.9 centimeters.
Super. We have an added advantage in this window that it will help us with part G.
So part G, we want to predict a temperature if the height is 18. So I wrote 18 is equal to negative 0.0293 T plus 26.5667. Now what I have to do is go back to the function. In F2, I'll write 18.
Super. Now we should see both, right?
Go to plot, and I do in fact see both there.
Okay.
Then we want to find the intersection, so menu, function, number 2, and with F2.
So 292.5 is the temperature in degrees Fahrenheit, for which the height of the cake will be 18. And even though 292.5 is a little bit outside of our given values, I would trust that number certainly much more than the result in part E.
Right. Now we want to answer the last question. Bob's friend Sean baked a cake at 370 degrees and it rose to a height of 15.5 centimeters. Based upon the model, who would have the tallest cake at 370 degrees? So we want to go to menu, go to 370, and F1 is at 15.7. So Bob's cake would be at 15.7. Sean's cake is at 15.5. So Bob's would be bigger.
So since 15.7 is bigger than 15.5, Bob's is a taller cake.
Bob's cake is taller.
All right. It takes a little bit to get used to any new piece of technology, so if there might be some parts of this video to go back to a little bit and watch a bit slower to really see which buttons we're hitting. But once you get the hang of it, it's pretty logical. All right?
Okay, bye.